Hello, I'm Nathaniel and today we are now going to do question 4 of MAT 2022. So, sketch the graph of y equals the x square root of x minus x over 4. Then we will basically have square root of x, and then the x over 4 will start to dominate as the x coordinate increases. Therefore, the graph will look something like this. Describe in words how the graph of this for x is greater than negative 1 over 4 is related to this. Now, it's incredibly easy to do this because all we need to do is just turn it from math to words. Negative 4x plus 1 over 4 minus 3/4 equals to negative x minus 1. Therefore, we can say that it is stretched by a factor of 1/4 and translated by the vector negative 1/4, negative 3/4. As you can see in the Desmos graphs here, which I have copy pasted from Desmos graphing calculator, you can see that it has this, the red graph is square root of x minus x over 4, and you realize that the blue graph, which is the transformed graph, has successfully been transformed. So, let us continue with the question. Point A is at negative 1, 0, and point B is at 1, 0. Curve C is defined to be all points P that satisfy this equation. So, what do? We take the Euclidean norm, which is the fancy math word for distance, and then use the formulas, and then we multiply them to get 1. Easy as pie. Find all points that lie on both the x-axis and also the curve C. Obviously 0, 0 is in, but then there are two other points which fit this definition as well. Because they do. Because then we have x plus 1 squared and x minus 1 squared. And if y is equals to 0, then by right, x plus 1 squared should be 0 at some point, and so does x minus 1 squared. But how do we know these points? Well, firstly, we can square both sides and remove the square roots. One counterintuitive point you might not think of is square root of 2, 0. So if we do this, square root of 2 plus 1 squared, then we don't need the 0 because 0 doesn't exist anymore, equals to 1. And then this product is actually deserved to be true because this is the silver ratio and this is the reciprocal of the silver ratio. The silver ratio delta, and it has the property that delta minus 2 equals to 1 over delta. And this delta is exactly the silver ratio. And also, a little known fact, actually a well-known one, is that the silver ratio actually comes out a lot in octagon geometry. And as a very biased reviewer of octagons, stating that they're really, really great for most purposes. After all, that's why I love octagons, basically. And this is why I like to see square root of 2 plus 1 in my calculations, because if I don't, then that makes me go insane. Just kidding. I just say that this occurs a lot. So find an equation in the form y equals to f of x. So we will just take x plus 1 squared plus y squared, x minus 1 squared plus y squared equals to 1. Then we have x squared minus 1 squared plus y squared, x plus 1 squared plus x minus 1 squared equals plus y to the power of 4 equals to 1. And if we can take off 1 from both sides, then this bracket will turn into x4 minus 2x squared, if you know your binomial expansions. Now the term in the middle corresponds to exactly 2 of x squared plus 1. This is because the x terms, x coefficients, 2x and minus 2x, just cancel out immediately. Y equals 2y squared x squared plus 1 plus x4 minus 2x squared equals to 1. Is actually equal to 0. So this basically means that we are now going to solve the quadratic. And you know the quadratic formula, this should be easy. Since this basically means that we will have a 4 minus 4ac and the b squared already have a multiple of 4 and square rooting it becomes 2 and the y coefficient is 1. Therefore, we can just take away the denominator at all costs. Yeah? Alright, let's move on. This basically means that if we simplify the expression here, then we have 4x squared plus 1. Then this means that y squared will have 2 plus minuses. Now, just because that there are 2 plus minuses doesn't mean that doesn't mean that the coefficient will result in plus, just because the signs cannot be both plus and both minus. It can be in either one of the other two microstates as well. Remember, 2 to the power n states and entropy, you know. So, since if we take this to be positive, actually this here, and if we take this to be positive, then we can get a positive x coordinate. If we take this as positive, we will get a positive y coordinate. Sketch the curve C. Since we know that it has 4 turning points and 3 x-intercepts, we can actually draw it. And it turns out to look like this. This made, in a math nerd like me, you will instantly recognize the curve. It's the Lemniscate of Balloonie. Actually, there's another Lemniscate, and it's called the Lemniscate of Gerardo, which is technically my favorite out of the two Lemniscates. So, I hope you enjoyed the little math lesson here, and remember, thank you all to who has watched this video. See you!